Good night, Miss Monse. Today I'm gonna demonstrate the heat of fusion on water. The goal of this experiment is to show that ice needs to absorb a significant amount of energy to change from a solid to a liquid, and that is happens without the temperature increasing during the phase change. Here I have three identical cups of glasses, and the cups are A, that is the one that has no water, B, that is the one that have 1 4 water, and C, that is the one that have a half of water. Well, as you can see, cup C melt first because it was at room temperature and because it was provided for more water than the other ones. And it has a larger volume. So now let's solve the problem, and let's calculate how much heat of fusion was for all. So we have here the formula, that is heat of fusion, that is equal to 334 joules per gram. You're gonna see it like upside down because my camera is upside down, but it's okay. My formula is mass per heat of fusion, and we calculate like the mass of the ice, that is from 20 to 30 grams. In this case I'm gonna put 25. First, we're gonna estimate the mass of an ice cube, just one, that is 25. 25 times 334 joules per gram, it's 350 joules. And now we calculate from the 3 ice cubes that we put in our cups, that it would be 75 times 334 equals 25,050. And that's our result, joules. Sorry, I don't put the joules, and that would be our answer. Now I'm gonna ask you questions. Why does ice melt faster in a cup with more water? Water is much better conductor of heat than air. In a cup with more water, there are more water molecules in direct contact with ice, transferring thermal energy much more efficient than air molecules in an empty cup. Which cup had more available of thermal energy? Cup C, ice and more water, because it had the largest volume of the room temperature water. It contained the largest reservoir of thermal energy to give up to the ice. Now, did the ice increase in temperature before melting? Technically, if ice drained from a freezer that is at 18 degrees, it warmed up to 0. However, during the melting process itself, the temperature stays exactly at 0 and it doesn't change until every bit of ice is gone. Where is the absorbed energy going? The energy is being used to break the hydrogen bonds that hold ice molecules in their solids, crystalline lattice. Instead of raising the temperature, kinetic energy, the energy increases the potential energy of the molecules to change their state. What does it mean, heat of fusion? In my own words, heat of fusion is the specific amount of hidden energy required to turn a solid into a liquid without changing its temperature. What possible experiment errors could affect your result? I think the ambiental temperature, but right now we have a very cool temperature, so I think that doesn't affect my project. Well, now I'm gonna say how much they take to melt. The one that had no water, it melt like it doesn't haven't finished, if you can see, but there have been happening like 10 minutes for it to melt. This one that it was the one that it was with more water was like 3 minutes and 45 seconds, and the one that have 1/4 of water, it takes like 6 minutes and 25 seconds to melt. Good night, Miss Monse. Pasa buena noche. Besos.